Imagine a city, alive and buzzing, but miles beneath its streets, a clock is ticking. This isn't a bomb, it's a colossal bubble of molten rock, stretching the Earth to its breaking point. Scientists watching it have a simple, chilling forecast. It's not a matter of if it will erupt, but when. For all of human history, the plan for this kind of threat has been pretty basic. Run, evacuate, hope for the best. But what if we didn't have to run? What if we could fight back? A handful of engineers and scientists have a plan to geoengineer the volcano itself. It's a plan so audacious it might just save millions of lives, or it could trigger the very catastrophe it's trying to prevent. Our planet has some monsters hiding in the basement. We call them supervolcanoes. While there isn't an official list, we know of about 12 to 20 of these behemoths scattered across the globe, each one a geologic time bomb. A super eruption is an event that throws out more than 1,000 cubic kilometers of rock and ash. To give you some perspective, that's enough stuff to bury a whole state under a thick blanket of debris. Right now, one of these giants is showing some worrying signs. In southern Italy, near the city of Naples, lies the Campi Flegrei, which means the burning fields. It's a massive caldera, basically a collapsed crater from an ancient, world-altering eruption. Over 4 million people live within its potential reach. For the past several years, the ground there has been swelling, pushing upwards as pressure builds. Since 2023, the frequency of earthquakes has steadily increased. This has prompted officials to raise the alert level to yellow and get detailed evacuation plans ready. Scientists warn that the crust of the volcano is being stretched to its limit, a state that can often come before an eruption. They can't say if it will happen tomorrow or in 100 years, but the system is clearly under a huge amount of strain. And if it goes, the consequences are hard to wrap your head around. A full-scale eruption at Campi Flegrei, or the even bigger Yellowstone caldera in the US, wouldn't just be a local disaster. It would be a planetary event. An ash cloud would shoot into the stratosphere, circling the globe and dimming the sun. Global temperatures could plummet, kicking off a volcanic winter that would last for years. Crops would fail worldwide. Supply chains would completely break down. It wouldn't be an extinction-level event like the asteroid that killed the dinosaurs, but it would be a catastrophe on a scale human civilization has never had to face. This is the scale of the threat, a danger so huge it pushes scientists to consider solutions that sound like they've been ripped from the pages of science fiction. If you knew a hurricane was coming, you'd board up the windows. If you knew an asteroid was headed our way, you'd try to deflect it. So if you know a supervolcano is getting ready to blow, what do? Do you just wait? Faced with a potential planet killer, some of the world's most brilliant minds have started asking a radical question. What if we could defuse a volcano? This isn't about building walls to stop lava. This is about performing planetary surgery, reaching deep into the Earth to treat the problem at its source. One of the most famous ideas came from a thought experiment by researchers at NASA's Jet Propulsion Laboratory, who were looking at the threat from Yellowstone. Their plan is both stunningly simple and ridiculously complex. The main idea is to cool the magma chamber. Think of a magma chamber like a giant, over-pressurized soda can. As more molten rock and gas build up, the pressure inside grows and the can swells, ready to burst. What the NASA team proposed is to carefully cool the can down. The pressure inside would drop. The threat would fade. The plan calls for drilling boreholes up to 10 kilometers deep into the rock around the magma chamber, not into it. Then they'd pump huge amounts of water down these holes at high pressure. As this water gets close to the intense heat of the magma, it would absorb that energy and turn into superheated steam at around 350 degrees Celsius. This steam would then be piped back to the surface. And here's the genius part, the detail that could make the whole multi-billion-dollar project pay for itself. That superheated steam wouldn't just be vented, it would be used to power a massive geothermal energy plant. A JPL researcher, Brian Wilcox, calculated that Yellowstone naturally leaks about 6 gigawatts of heat. By tapping into it, they could generate enormous amounts of clean electricity at competitive prices, potentially for tens of thousands of years. In theory, the plan would turn one of the greatest threats to humanity into a nearly limitless source of clean energy, all while slowly bleeding heat from the volcano and lowering the risk of eruption. Based on their calculations, NASA estimated that removing about 35% of the heat would be enough to prevent a future cataclysm. And this isn't just a fantasy on a whiteboard. In Iceland, a project called the Krafla Magma Testbed, or KMT, is getting ready to do something remarkably similar. In 2009, an engineering team accidentally punched right into a pocket of magma just over 2 kilometers down. Now, an international team of scientists plans to go back, with the goal of drilling into the magma on purpose by 2026 or 2027. They want to create the world's first magma observatory to study this molten rock and pioneer a new generation of superhot geothermal energy. This is the first step. Humanity is learning how to walk in the land of giants. This is where the story takes a turn, where the brilliant, heroic plan starts to sound terrifying. The proposal to cool Yellowstone and the real-world work at Krafla are an incredible leap of ambition, but they force us to ask a really uncomfortable question. By trying to stop a natural disaster, could we accidentally create a man-made one? The single biggest risk is accidentally triggering the very eruption you're trying to prevent. The rock sitting on top of a magma chamber is called the caprock. It's what keeps all that pressure contained. Drilling deep into the Earth's crust in such a volatile place is incredibly risky. A mistake or an unexpected fracture could crack that caprock, causing the magma chamber to suddenly depressurize. That could lead to an explosive release of gas, triggering the exact super-eruption the project was meant to stop. It's like trying to defuse a bomb and accidentally cutting the wrong wire. Even if you don't set off the big one, the list of potential side effects is long and worrying. What happens when you pump millions of gallons of water deep into the crust? Could it lubricate old faults and set off swarms of earthquakes? Could it create new pathways for toxic volcanic gases to seep into underground aquifers, poisoning the water supply? Then there's the risk of a hydrothermal explosion. If water hits the super-hot rock near the magma and flashes to steam too quickly, the sudden expansion could be violently explosive, blasting rock and steam into the sky with devastating force. These risks are so huge that many volcanologists are, to put it mildly, skeptical. Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, has called the NASA proposal a thought experiment that was never taken seriously by the people who actually study volcanoes. He argues the whole idea is flawed. A volcano like Yellowstone isn't just a hot pocket of rock. It's connected to a massive plume of heat extending deep into the Earth's mantle. He suggests that trying to cool it would be like trying to cool a bonfire with an eyedropper. It would be pointless, and dangerously so. This all boils down to an ethical idea known as the precautionary principle. It basically says that if an action has the potential for widespread, irreversible harm, the burden of proof is on the people proposing it to show that it's safe. With volcano geoengineering, the uncertainties are massive, and the consequences of failure are absolute. So, Plan A is to stop the volcano from erupting. But there's a Plan B that's even wilder. Instead of stopping an eruption, what if we just copied one of its biggest effects? This is the other side of volcano geoengineering: solar radiation management. When the massive Mount Pinatubo volcano erupted in the Philippines in 1991, it shot millions of tons of sulfur dioxide into the stratosphere. There, The gas mixed with water and formed a hazy layer of aerosols that spread around the world. This haze acted like a planetary sunshade, reflecting a little bit of sunlight back into space. The result was measurable. Global average temperatures dropped by about 0.5 degrees Celsius for a couple of years. Solar geoengineering proposes to do this on purpose. The idea is to use a fleet of high-altitude jets or balloons to continuously spray tiny sulfate particles into the stratosphere, creating an artificial, permanent volcanic winter to fight global warming. On paper, it's a shockingly cheap and effective way to turn down the planet's thermostat. But just like drilling into a volcano, the risks are staggering. Scientists warn this is a highly risky strategy. While computer models suggest it might cool the planet overall, it could have wild and unpredictable effects on regional weather. Cooling the northern hemisphere, for example, might accidentally cause catastrophic droughts in Africa. It could also deplete the ozone layer or cause acid rain. And then there's the biggest nightmare of all: termination shock. Imagine we get hooked on this artificial sunshade for 50 years while we keep pumping out greenhouse gases. What happens if we suddenly have to stop? A war, an economic collapse, anything. The aerosol layer would dissipate in a couple of years, and the full, unblocked force of decades of warming would hit the planet all at once. The temperature spike would be so fast and so extreme that ecosystems and civilization would have no time to adapt. It would be a global fever from which we might never recover. We're standing at a crossroads, armed with technology that gives us the power to alter the planet itself. The problem is, our wisdom hasn't caught up. These are some of the biggest questions our species will face in the coming decades. Is the risk of a radical plan greater than the risk of just doing nothing? And who gets to decide? Who gets to turn the planetary thermostat up or down? What do you think about these wild ideas? Should we be pursuing this research, or are there some doors that are better left unopened? Let us know your thoughts in the comments. We're in a strange and fragile moment in history. The same natural forces we once blamed on angry gods are now coming into focus. We can see the threat building, we can measure the pressure rising, and for the first time we can actually draw up blueprints to fight back. The whole dilemma of volcano geoengineering is a perfect snapshot of the 21st century. On one hand, doing nothing when you know a civilization-threatening disaster is on the way feels irresponsible. If we have the power to save millions of lives, aren't we obligated to try? But on the other hand, there's the danger of hubris, the belief that we can control systems we barely understand. The history of science is filled with stories of unintended consequences, of trying to solve one problem and accidentally creating 3 new ones that are even worse. When you're dealing with the planetary operating system, a single bug can crash the whole program. The path forward is anything but clear. These plans aren't happening tomorrow, but the research is happening now. The drilling in Iceland is moving forward. The debate is getting louder. We're at the dawn of a new age, where humanity has to decide if it's going to be a passive inhabitant of Earth or an active manager. The question is, are we ready for that promotion? Is this the start of our role as responsible custodians of our planet, or is this a final, fatal mistake, a cautionary tale written in stone and fire?